Okay, now we're going to try to figure out the probability of something that involves combinations. So I got this problem here. In a recent survey of 25 voters, 17 favor a new city regulation and 8 oppose it. Find the probability that in a random sampling, so if you just chose someone randomly, of 6 respondents from this survey, 2 of them would favor it and 4 would oppose it. Okay, now this problem is kind of similar. The first part of this problem is kind of similar to the last problem where we were dealing with the smoothie. We got different types of fruit and vegetables and things like that. So let's highlight this information to try to organize it together. We have 17 that favor a new one, and we are going to try to choose 2 of those, right? And we have 8 that oppose it, and we're going to try to figure out how to choose 4 from those 8 that oppose it. So let's find the total number of outcomes in the event using the fundamental theory. So first, let's start with the 17 that favor or 17 favor it, but we're only choosing 2 of them. So we're going to have 2 spots. So let's get out of there. We're going to have 2 spots for those that favor. That's not right either. There we go. And we want to make that green. Yes, we do. So we're going to choose 2 that favor it, right? And since we're choosing 2 that favor it, but there are 17 that favored it, so we have 17 options for the first spot and 16 for the second. And we're going to divide that by how many times we can arrange that, which is 2 times 1. Okay? Now moving on to the ones that oppose it. We're going to try, in this sampling, 4 oppose it, right? So we're trying to find that 4 that oppose it. 1, 2, 3, 4. And since there were 8, so that's 8, 7, 6, 5, okay? And we got to divide that by our 4 factorial, or 4 times 3 times 2 times 1, or how many people you're choosing for this. And then we just multiply this whole thing together. And that's going to find the number of outcomes in the event that are possible for this scenario. Okay, so let's put that in our calculator really quick. We have 17 times 16 times 8 times 7 times 6. Oh, 5 and then 6. I just did it in the wrong order. It doesn't really matter. Figure out what that is, and we're going to divide that by 2 times 4 times 3 times 2. Okay. So in the end, there are 9,520 different ways you can choose 2 people that favor it from 17 and 4 people that oppose it from 8 who opposed it. Okay, so if you're choosing 6 people randomly. Okay, now the next question is find the number of outcomes in the sample space. That's the next part to answering this question, is to find the number of outcomes in the sample space. Now to do that, this one's a little easier. There's 25 voters, and we were choosing 6 from the 25 voters, so that's 6 spots, right? 4, 5, 6. So 1, 2, 3, 4, 5, 6. And for the first spot, you have 25 options. The next spot, 24, then 23, then 22, then 21, then 20. But remember, we have to divide that by how many different spots there are, and that's the same as 6 factorial. Okay, so 6 times 5 times 4 times 3 times 2 times 1. So let's put that into our calculator and figure out what that is, this total sample space right here. So we have 25 times 24 times 23 times 22 times 21 times 20. Figure out, do I put that in right? Yeah, it looks good. And we're going to divide that by 6 factorial. And we get, there are, if you're going to choose 5 people or 6 people from 25 voters, there are 177,100 different ways to do it. So 177,100 ways to do it. Okay? So now, to find the probability, remember, probability is just how many ways an event can happen divided by the total number of ways in a sample space. So well, we have the total number of ways in a sample space, that's right here. And we have the number of ways an event can happen, that's right here. So really what we need to do is just divide these two. We just need to take 9,520 divided by 1,777, 100. And that will give us the probability of choosing from 6 people, 4 that oppose this, and 2 that are in favor of it. So let's just put that in our calculator to figure out that probability. So we got 9,520 divided by 1,700, or 177,100. And that gets us 0.053, which is actually equal to 5.3% chance of you choosing this scenario.